side pressure. And we can also use PMT test. It's a side pressure matter test to get the empirical relationship. Bolotti and his teams proposed the empirical relationship of Gmax of Zhang. Is Gmax over GURC larger than 3.6, less than 4.7 is a range. And Bayer and his teams proposed the empirical relationship of sound. Gmax is equal to 1.68 over alpha p times the GUR. GUR is a modified modulus in the unloading and reloading test. Unloading and reloading in the PMT test. That's GURC. And GUR is the second modular of unloading and reloading process in PMT. And this value depends on the parameters of the unloading reloading stress state. And is also based on the theoretical in situ test result. Let's see. Let's make a conclusion. Make a conclusion of G over Gmax. This is the effects in this table. The result, the effects of environmental and loading to clay and clayey soil is given. Here we can find the factor sigma m prime. When this factor increase, then it will cause the Gmax increase too. And if volume ratio E increase, then it will cause the Gmax decrease, Gmax increase. And if cement increase, then it will cause Gmax increase because the soil will turn too hard. And OCR, if OCR is large, then the level of over consolidation tend to serious. Then it will cause Gmax increase. And the plastic index PI have two results. If OCR larger than 1 is over consolidated soil, then Gmax will increase. If OCR equal to 1 is normal consolidated soil, then PI will not affect Gmax. Is a constant. Gmax is a constant. And for strain rate, gamma point. For normal plastic soil, no effects. But for plastic soil, it will cause Gmax increase. That means the strain rate increases logarithm cyclic, and it will cause the Gmax increase 10%. And the cyclic number of loading increase, it will cause the Gmax of clay decrease, but it will cause the Gmax of sand increase. Now we can find for clay and sand, the behavior is totally different. Then let's see the attenuation mode, G or Gmax. And G is a function of strain, and the ratio of G over Gmax is also a function of strain. Ishibashi and Zhang unified the influence of effective confinement pressure sigma m prime and the plasticity index IP on modulus attenuation characteristics by the following formula. Alpha 0 equal to is a ratio G over Gmax is a function of string and pi and times the sigma m prime powered by m minus m. Function k is given in this equation, and m is also a function given in the following equations. Now let's see. Usually we use some laboratory test. We can find the shear modulus divided by the maximum value, the ratio. We get the ratio and the corresponding shear strength. We mark this point, and we can fitting the range curves of the area. Then the center curves can use to create an Japanese scientist Zen Koki from Kyushu University is also did some laboratory test and proposed the relationship between the G over Gmax and the shear strength. They gave groups of curves with different IP. IDRISS also did a laboratory test and gave his curves. This is for over-consolidated soil, and the OCR, over-consolidated ratio, is from 1 to 15. And we can they gave groups of curves with different PI, from 0 to 200. Ishibashi proposed groups of curves give the empirical relationship G over Gmax and shear strain amplitude. They have a different stress state in each curves. And the PI is not same. They left figure for PI equal to 0, and the right figure is PI equal to 50. And under the condition figure for PI equal to 0, and the right figure is PI equal to 50. And under the condition of stress-controlled harmonic loading, for a given soil sample, the shear strain amplitude caused by pore water pressure and structure change increases with the increase of cycle times. Under the condition of undrained strain-controlled harmonic loading, the amplitude of shear stress decreases with the increase of number of cycles. Both these two cases indicate that the stiffness of soil sample tends to degrade under cyclic loading. For cohesive soil, the shear modular Gn and n cycles is related to the modulus value G at the first cycle according to the following relationship. Gn equal to delta times the initial shear modulus G1 of first cycle. Then delta is just equal to n. N is degradation parameters. T is decrease N powered negative T. T is decay coefficient proposed by IDRISS in 1978. The degradation parameter decreases with the increase of plasticity index and the over-consolidation ratio, but the increases with the increase of cyclic shear strain amplitude. Now let's conclude the result. If sigma m prime increase, it will cause the Gmax increase. And if volume ratio increase, it will cause the Gmax increase. Or the geology time increase, it will cause Gmax increase. And the salmon increase maybe cause the Gmax increase. OCR increase, no effects to the Gmax. And plasticity index increase, it will cause Gmax increase. And cyclic strain, gamma C, will cause the, if this value increase, it will cause Gmax decrease. The shear strain rate, if the shear strain rate increase, it will cause the Gmax increase. And the cyclic number of loading N increase. For clay, it will cause the, this ratio decrease. And for sand, it will cause this ratio decrease in undrained condition, but increases in drained condition. Here, undrained condition, sand in undrained condition is similar with the clay. But in drained condition, it's totally different. Let's see the variation mode of equivalent viscous damping ratio. For coarse clay or sandy soil and fine-grained soil clay, SEED and IDRISS respectively summarized the existing test result and gave the nonlinear variation law of damping ratio CEQ with shear strain gamma. That is, the average value of upper and lower limit range of CEQ is a function of gamma, as shown in this figure. Then rockfill and gravel soil are studied and compared with damping characteristic of sand. Both are very close, as shown in the figure. This figure is for clay. They get some point, and they mark the range, upper and lower range of each, and get the average value and create empirical relationship of the clay. And for sand is similar with clay. And they create the upper and the lower range and get the average value of it. This is the curves for gravel. Depends on the test. As the normal modular, attenuation characteristics are affected by the plastic properties of soil. The study of Kokushio Koji and his teams, and Dobry and Vasitic and Sun showed that the plastic index also affects the change mode of the damping ratio, as saw in the following figure. This is for an over-consolidated clay. OCR is from 1 to 8. Here they gave a groups of curves with different PI. from 0 to 200. Where we can find that the PI will affect the change mode of damping ratio. The damping ratio is also affected by the effective confinement pressure, especially for low plastic soil. Ishibashi and Zhang proposed an empirical relationship of damping ratio of plastic and non-plastic soil in 1993. Firstly, the modulus ratio G over Gmax, or modular attenuation factors, was calculated by the following formula, and then the damping ratio was calculated by these formulas. Damping ratio Kc equal to 0.333 times the 1 plus E powered by negative 0.0145 pi powered 1.3 and divided by 2, then times another terms with G over Gmax. Then let's conclude the damping ratio characteristics, the effects of environmental and loading to damping ratio of clay and clay soil. And if sigma m prime increase, it will cause the damping ratio decrease. That means the soil tend to hard. If water ratio increase, that means the soil tend to soft. Then it will cause the water ratio decrease. And for geology times, if the times increase, maybe it will cause the water ratio decrease. And if salmon increase, it may be cause the water ratio decrease. And for over consolidation ratio, no effect to the water ratio. Plastic index, the IP increase will cause the Kc decrease. And the cyclic shear strain gamma C increase will cause the Kc increase. Kc water damping ratio increase. Shear strain rate gamma point increase. It will maybe cause the it will not affect the water ratio, and maybe cause the damping ratio increase. For cyclic number of loading increased, maybe no effects to the damping ratio. Okay, that's all for this part 1.